Open your mouth. Right now, open it. Somewhere in there, trapped in your dental plaque, are chemical traces of everything you've eaten for the past several months. Scientists can read them. And when they read the dental plaque of people who lived 3,000 years ago, they found an antibiotic inside. The same one officially invented in 1948. Ancient people were taking antibiotics 3,000 years before humanity had any idea what a bacterium even was. Right now, inside your body, there's a war going on. Not a metaphor, an actual war. Your neutrophils, white blood cells, are surrounding bacteria, injecting them with poison and rupturing their membranes from the inside. Right now, every second, while you're listening to this. 100,000 years ago, that was the only medicine that existed. It worked. Otherwise, you wouldn't be here. 1960. The Zagros Mountains, northern Iraq. Shanidar Cave. Paleoanthropologist Ralph Solecki from Columbia University is crawling on his hands and knees into the dark with a flashlight, looking for bones. He finds a Neanderthal, 65,000 years old, lying carefully on his side, deliberately arranged, and all around him, pollen. Solecki calls in a botanist. The botanist looks at the list of plants and goes quiet. Yarrow stops bleeding. Ephedra opens the airways, the basis of modern asthma drugs. Groundsel, pain relief. Spurge, antiseptic. 8 species, 8 medicinal functions, 65,000 years ago. These aren't grave flowers. This is a first aid kit, placed in the tomb of someone who knew how to use it. And here's what completely breaks your brain. Nobody taught this Neanderthal pharmacology. He just knew. Generation after generation, thousands of years of observation, thousands of deaths, and eventually, precise knowledge. This plant stops blood. This one opens breathing. This one kills infection. Now, chimpanzees. And this is where your jaw should hit the floor. Tanzania, 1997. Biologist Michael Huffman from Kyoto University's Primate Research Institute is sitting in the forest with binoculars. Next to him, a sick chimp. Bloated abdomen, barely moving, intestinal parasites. The female stands up, walks, slowly, several kilometers through jungle. Arrives at a tree she has never eaten before. Vernonia amygdalina, bitter leaf. Starts chewing not the leaves, not the fruit, specifically the pith of the stem, the most bitter part of the entire plant. Huffman takes notes, doesn't understand. Next morning, the parasitic load in her gut had dropped by a factor of 20. 20 times. Overnight. From a plant she chose herself. The local people of Tanzania have been treating stomach illness with that same plant for thousands of years. The chimpanzee had not been talking to the locals. This knowledge isn't learned. It isn't passed down through words. It lives somewhere deeper than language, deeper than memory, in biology itself. And it lives in you too, right now. You've just forgotten how to hear it. Now, aspirin. Brace yourself because this one's going to sting. 1897. Felix Hoffmann, a chemist at Bayer, synthesizes acetyl salicylic acid. Patent filed. Name: aspirin. Textbooks call this a landmark discovery of modern pharmacology. A discovery. The Ebers Papyrus, written in Egypt in 1550 BC. It's real. It's sitting in the University of Leipzig right now. You open it and read, willow leaves, for fever and joint pain. Specifically willow, specifically fever. In the bark of white willow lives a molecule called salicin. In the body, it becomes salicylic acid, the same active compound that's in aspirin. Kills pain, reduces inflammation, breaks a fever. The Sumerians knew this in 3000 BC, the Egyptians in 1550. Hippocrates prescribed willow to women in labor for pain relief. And a Neanderthal and this is actually documented, a Neanderthal from El Cidrón Cave in Spain, who died 50,000 years ago, was eating willow bark before his death. The dental plaque analysis was published in Nature in 2017 by Laura Wyrick's team at Cambridge University. For 50,000 years, people chewed willow bark. Then Hoffman added an acetyl group and filed a patent, and we call that a discovery. Mold. Hold on tight. September 28, 1928, London. Alexander Fleming comes back from vacation. On a petri dish of bacteria, a patch of penicillium mold. Surrounding it, a dead zone. Not a single living bacterium. Fleming looks, understands. Penicillin, Nobel Prize, millions of lives saved, the greatest discovery of the 20th century. Now, 2018. Aditya Sudha from the Smithsonian Institution takes dental plaque from Egyptian mummies, 3,000-year-old ones, runs mass spectrometric analysis. Tetracycline, an antibiotic, officially discovered in 1948, found in the teeth of people who died 3,000 years before antibiotics were invented. Sit with that for a second. In the teeth of people who died 3,000 years before antibiotics existed, there were antibiotics. How? Beer. They brewed it and stored it in unglazed clay vessels. Living in the walls of those vessels, Streptomyces mold, the exact same organism scientists would later use to synthesize tetracycline. They drank that beer every day. They were dosing themselves with antibiotics every single day for 3,000 years. The wildest part, the study found that Nubian mummies from this period show almost no evidence of bacterial bone infections. Almost none. Clean bones, healthy bones. They didn't know the word antibiotic. They just noticed, this beer makes us feel better, so they kept drinking it. Fever. And here's where medicine spent centuries getting it completely backwards. Your temperature reads 100.4. You reach for the Tylenol. Makes sense. Fever is bad. Bring it down. Except your body has a very different opinion. 2011. Tokyo Medical University, Journal of Leukocyte Biology. Result. At a body temperature of 101.3 degrees Fahrenheit, your immune cells move toward the site of infection 31% faster. At the same time, viruses at this temperature lose their ability to replicate properly. Their proteins start breaking down. Fever slows the enemy and speeds up your army at the same time. This isn't a glitch. It isn't a side effect. It's an ancient weapon, refined over hundreds of millions of years of evolution. And yours works exactly the same as the first mammals. And every time you pop Tylenol at 100 degrees, you're calling a ceasefire at the exact moment your side was starting to win. That doesn't mean suffer through everything. High fever is dangerous. 104 degrees is a completely different situation. But 100.4 isn't the disease. It's the treatment. Your body isn't breaking down. It's working. Here's a number that's hard to think past. 83%. 2019, University of Groningen, PLOS 1. Scientists take 122 plants from folk medicine traditions. Every continent, the Amazon, Central Africa, Siberia, Pacific Islands, Central Asia. Different peoples, different languages, different millennia. They test every single plant in the lab. 83% had precisely the molecule that explains precisely the healing effect the folk tradition claimed. 83% accuracy. No microscopes, no chemical formulas, no clinical trials. Every mistake cost a human life. So, over hundreds of thousands of years, the mistakes got weeded out. This is the longest and most brutal clinical trial in the history of the planet, and it hit 83% accuracy. Modern clinical trials for new drugs end in approval roughly 10% of the time. Chew on that. And finally, the most human thing of all. Neuroscientist Dakayane Sherman at the University of Texas at Austin in 2014 scanned the brains of sick people, looking for what happens inside. Here's what he found. Illness activates the same neural networks as social rejection. The feeling of being abandoned, of being alone, of nobody giving a damn. To your brain, a stomachache and loneliness are neurologically indistinguishable. Your ancestors hadn't read Neuroscience Journal, but they knew it in their bones. Which is exactly why the sick were never left alone. Never. Someone went for bark, someone kept the fire going, someone just sat down next to them and said nothing. Sitting with someone who is sick is not politeness. It's not a social custom. It's a medical intervention. Literally. It changes the biochemistry of the brain. And it's the only medicine that has existed for 300,000 years and still can't be manufactured into a pill. That blister pack in your medicine cabinet, the molecule inside it traveled a long way to reach you, through the dental plaque of mummies, through mold on clay vessels, through tree bark by a fire in the dark, through the hands of a Neanderthal who chewed it in a cave and felt the pain begin to lift. Hoffman, Fleming, Waxman, they didn't create medicine. They were just the first ones to write down what the human body had always known. You take the pill, swallow it, and somewhere in that gesture, 100,000 years of memory. Thank you for watching. Stay tuned. We're already working on a new and exciting video for you.